The center section, as far as I know, is where almost all measuring systems are calibrated from. That's your starting point.
We typically always start in the center of the vehicle, and we pick measuring points that are undamaged. So you kind of have a side hit with side damage. You just want to pick measuring points that are out of that damage area.
And if there is damage, the base is still the base. We want to correct that and then still continue to work out up from that.
When we look at starting with a measuring system, we really need to look at the base of the vehicle. We need to go to points that were possibly fixtured by the manufacturer when the vehicle was manufactured. So the points that were held in rigidity as the vehicle was being built. So we're talking about your torque box corners.
Well, any fixture points are typically more accurate than, let's say, a cradle bolt. You know, cradles can be moved around, bolts can get loose or get bent.
And we get, in a lot of cases, CAD data from the OEMs or control points that they would recommend we start off with. Those would be what we would refer to as your primary control points, the main points that you definitely want to be measuring.
Your initial measurements in the center section will dictate if you can use those points from how the measuring system looks at those measurements once they're taken. If there is a large tolerance or a large amount of misalignment in that center section, it's going to ask you, do you want to continue or do you want to reject and find different points? Maybe there's some inertia damage that's moved into the center section. It wants you to identify that first before you use that possible improper center section to be able to measure from.
Our system's got some fail-safes. You'll actually, what's called you'll fail centering. So it will prompt you, give you an audio clue that you've got something wrong. And then even if after we pass our centering, we can actually go into centering diagnostic, and it will tell us how accurate our centering is.
If there's severe damage, we also give alternative base points to measure off of, and we can calibrate for length, width, and height off of 3 points in that center section. We can still see the damage so that we can monitor that as we start to correct it, and when it's back in the correct alignment, then we can either finish the repair in a 3-point or go back to a 4-point measurement and repair the vehicle.
I think if you want to look at the basic things that technicians need to keep in mind, they need to look to make sure that they're using the right adapter, that they're absolutely on the right point, and they're on the right side of the car, or the left side of the car if that's the point that they're trying to measure.
Common pitfall for the technician is choosing the correct data sheet. And that's where we start when we start our measuring process.
Especially when you start to get into full frame trucks, different wheelbases, different door configurations, 2- and 4-wheel drive, same thing with sport utilities. All those need to be checked pretty closely to make sure that you have the right data for the vehicle.
What we're looking at in the center section is we're going to identify which points to measure. We're going to tell you exactly how big the reference point is as far as dimension and give you the attachment recommended for that. Now, there's cases where that attachment may not fit or you've run out of attachments. You can use an alternative attachment that may be a different height measurement or a different center of the hole is the center of the hole, but it may affect your height measurement depending on the adapters. So if a technician uses a different adapter when setting up, he has to tell the computer system that he's changed attachment.
The Spinisi measuring system uses 3 length probes. What we point to and what we touch is what we measure.
On our data sheet will direct you if you're going to use a 25 millimeter cone or a 35 millimeter cone, or if it's going to, we're going to go around like a 12 millimeter bolt. So there's different adapters for bolts, holes, for doing angle measurements as well. There's, once again, called out on the data sheet which one to use. We also have a few workaround tools to get around something like an exhaust pipe or maybe a brake line.
Within computerized measuring system, the information provided by the technician, the system's only as good as the information being provided.